All right, we are continuing on with our square roots chapter, and we are looking at adding and subtracting square roots. Okay, so the first thing I want to talk about, let's go back a little bit and talk about polynomials. So if we were to ask you to add 3x plus 4y plus 5x, what we would do is we would look here and we'd say, oh, I'd take the 3x and add it to the positive 5x because they are like terms, because they have the same variables. So 3x plus 5x gives us 8x. Then I would take the 4y and just bring it over. So when I added that, I would get 8x plus 4y. In polynomials, remember we only added, subtracted like terms, which meant that you had the same variable and you would add or subtract the coefficients. Well, square roots are no different. In square roots, we need like radicals, meaning the radicand, the part inside, must be the same in order to add or subtract the coefficients. So for example, 5 square root of 3 plus 6 square root of 3. When we look, notice our radicands are the exact same. So I have 5 square root of 3 plus 6 square root of 3. I'm going to take the coefficients, 5 and 6, and I'm going to add those together, and that would give me 11, and I still have square root of 3. Okay? So I would just take my coefficients, add or subtract them, and bring over the radical. Now, if the radicands are not the same, okay, so if you look at them and they are not the same, then what you must do is you must simplify the radicals to try and get them to be the same. Once in a while, they still won't be, but your first thing you should always do is simplify all of your radicals. Okay, so if I look here, I have a 2 and an 8. Well, the 2 cannot be simplified, so I'm going to leave it 3 square root of 2. But the 8 has a perfect square. It's a square root of 4 and 2. So what I can do now is the square root of 4 comes out, becomes a 2. So that would turn that into minus 12 square root of 2. So now we have 3 square root of 2 minus 12 square root of 2, which gives me negative 9 square root of 2. Okay, so the rule there is we have to simplify our radicals and then look for like radicals when we add and subtract. So let's just go over those steps. So step 1, what you're going to do is you're going to make sure that all of your radicals are in simplest form. In other words, you're going to take out the perfect square factors from the radical. The second thing we're going to do is then we will add or subtract the coefficients of the like radicals. So the radicals that have the same number inside, the same radicand. Now, remember when you add or subtract, you add or subtract just the coefficients. The radicals do not change, okay? So the radicals themselves, so square root of 3 stays square root of 3, square root of 2 stays square root of 2. Those do not change, just the coefficients, the numbers in front of the radicals are the ones that change. All right, so let's give it a shot. Let's try a couple. So I look here at number 1, and I notice I have square root of 5, square root of 5. So those are like radicals. So what I'm going to do is I'm going to take the 3, and I'm going to subtract 7. So 3 minus 7 is negative 4, and then I bring the radical across. So negative 4 square root of 5. Okay, let's try number 2. So I look over here. I have a 3 and a 3, so my radicals are the same. So I'm going to take negative 1, add it to 7, and that is going to give me 6 square root of 3. Okay, so notice those both had like radicals. Okay, so on number 3, I look and I say, oh, wait a minute, 12 has a perfect square factor. So what I'm going to do is I'm going to do a quick simplify on that. So 12 has a 4 times a 3. So now we take that and we say the square root of 4 is 2. So I'm going to take that 2 and times it. So this is now going to turn into 12 square root of 3 plus square root of 3. Well, now if you notice, my radicals are the same. So I'm going to take the 12, add it to 1, and that gives me 13 square root of 3. Okay, let's try this next one, number 4. So I look across, I say, oh, wait a minute, I have the 4. So I have 7 square root of 2. Nothing changes there. But now I'm going to simplify the second one here. 18 has a 9 that goes into it. So now I'm going to take the 9 and say, okay, square root of 9 is a 3. So that times that 4 then. So what I really have here is I have 7 square root of 2 minus 12 square root of 2. So now I have like radicals. So I take 7 minus 12, which gives me negative 5 square root of 2. Okay? Now, just a little hint there is when you look at these problems, the radicand of the other one kind of gives you a hint of probably what you're going to be looking for. Okay? On these last 4 then, we look at this first one, number 5, we're looking to simplify. So we start off and we say, okay, I have 6. Now I look at the square root of 20 and I break it down and I say, okay, that is 4 times 5. So then I come in here and I say, okay, the square root of 4 is 2. So that is going to turn that into 12, because remember we take that 2 times the 6, square root of 5. Then over here, I do the same thing. I still have minus square root of 45, and square root of 45 breaks down. The largest perfect square that goes into 45 is 9. So now I simplify that. The square root of 9 is 3. That's going to bring that out. So that's going to leave us with minus 3 square root of 5. Okay, so if I have like radicals now, so I'm going to take my 12 and I'm going to subtract 3, and that's going to give me 9 square root of 5. Okay, let's try another one, number 6. So the first thing I notice here is I need to do some simplifying. So I have negative 2 square root of 27 has a perfect square of 9. So I'm going to break that apart. 75 has a perfect square of 25. I'm going to break that apart. So I look over here. The 9, the square root of 9 is 3. So I'm going to bring that out. 3 times the negative 2 gives me negative 6 square root of 3. Then I come back here. Square root of 25 is 5. 5 times the 6 is going to get me 30 square root of 3. So now we take and we add those. 30 plus a negative 6. That's going to get me 24 square root of 3. And I can add those because my radicals would be the same there. Okay? Now, this time I have 3 expressions. But does that change anything? And the answer would be no. So I look here, 8's going to need to be simplified, and 32 is going to need to be simplified. The 3 can't be. So I'm going to start in, and I'm going to say, okay, 2, 8, the largest perfect square that goes into it is a 4. So I'm going to simplify that. We said the square root of 3 here, not going to touch it. Over here, I have the square root of 32. So when I look at my list, the square root of 32, the biggest one is 16. So now I come back and I start to simplify these. So the square root of 4 is a 2. So I bring that out, and that's going to make it 4 square root of 2 plus 4 square root of 3. And then over here, I have 16, which is a 4. So I'm going to bring that out, times it to the negative 6. So that's going to give me negative 24 square root of 2. Now I look for like radicals. So I notice I have a 2 and a 2. So those can go together. So now I'm going to take 4 minus 24. So 4 minus 24 is negative 20 square root of 2. This here in the middle, the square root of 3 is not like to those. So it is just going to tag along. So I end up having negative 20 square root of 2 plus 4 square root of 3. Okay, last one. Now on this one, you'll notice there are 4 of them. Still, no different, just more simplification that has to happen. So I start in and I look at the 20, that's going to need to be simplified. The 54 needs simplified. The 18 needs simplified. And the 24. So all of these radicals need simplified. So I'm going to start off with the 20. I look at my list. What's the largest perfect square? And it would be a 4. So then I go over here to the 54. And I look at what's the largest perfect square. And that one would be a 9. Then I come over here, square root of 80, and I do my math, and the largest perfect square there is a 16 times 5. And then I look at my 24, and the largest perfect square there is a 4 times the 6. So now we come back to simplify these. So square root of 4 is 2. So I'm going to bring that out, and that's now going to get me 3 times 2, which is 6, square root of 5. On the second one here, I have the square root of 9. I bring out that 3, and that's going to get me negative 15 square root of 6. Then I come in here, the square root of 16 is a 4. So now I'm going to get 4 times 2, which is 8 square root of 5. And the last one here is a square root of 4. I'm going to bring that out. That makes a 2. So that's going to give me minus 2 square root of 6. Okay, so now we look for like radicals. So I have a square root of 5, square root of 5. So I'm going to take the 6 and add 8 to it. And that's going to give me 14 square root of 5. Then I look and I say, okay, is there any others? And I have square root of 6 and a square root of 6. So I'm going to take the negative 15 and add to it a negative 2. And that's going to get me negative 17 square root of 6. And that would be my final answer. So when you look at adding and subtracting, it's really no different than when we were combining like terms. The only difference is the only difference is you have to simplify your radicals first. So once again, it comes back to that simplification. You have to simplify, then you can add your like radicals. All right, have a great one.